You know what? Uh, no, it's a bit distorted. I think you need to start again. Maybe the internet maybe or I mean, I'm not able to hear you. What you're saying? Hmm, maybe maybe I should start. Maybe I guess. Maybe you can restart this meet, or maybe I mean restart the studio somehow. Um, uh, okay, so yeah, people are saying that your voice is not clear. It's fast forward. Yeah, even I'm hearing that. Uh, okay. So I'll just get started with the. Okay, I'll just share my screen and then I'll get started. I hope my screen is visible, right? Mm, okay. So, okay, very good afternoon to everyone who are present here for today's session. So today we'll continue where we left yesterday with reading and writing some data files of some specific format. So as today, as I understand, today we'll be doing a bit more of reading the file in a different format, right? Yesterday we did using NumPy's load.txt format. If you attended a session here, I'll just forward on to yesterday's package. Okay, so basically some we saved some file name with tutorial.txt yesterday, and we saved it with this file name. It's just a one-dimensional array, and when we added two more functions, two more different types of data sets with two different columns, we had this as in two sets of columns, and then we actually called up using this load.txt function of numpy, and then we simply loaded the data into different arrays and then simply plotted it. So that was a very simple simple method to just plot using txt and having one or two data columns as your data in the saved file. So today I'll be just showing how you can read the files in a specific format. Let's say you have this file named this Jupyter underscore full, which I guess is the file which must have been shared in the group. If I'm if I'm correct, maybe, or maybe this can be shared again in the group. So this Jupyter underscore full is basically the uh, arrays and declination of Jupiter in the sky on certain dates. So to basically import these files into our system, what I've done is I've taken some uh, I've just taken some particular format to have it. And how did I do that? I simply read a particular library which is called Pandas. So Pandas is a very strong library for reading and writing files and also tables. So it's a very good library to do that stuff, and also to create different types of data frames. You can read it in some specific format. You can convert them into some specific format according to what type of work you want to do. right? So you can simply load your file using import underscore pandas. So also yesterday I was actually ma'am made me ma'am told me that we weren't able to import this AstroPy library or some other libraries into the online Jupyter notebook that we tried. So I'll give you an alternative if that's the thing. And if you haven't installed Anaconda, what you can do is you can simply go to Google Colab. So just search for Google Colab, and you'll reach on to this particular link, which is something like this. You just go on to that, and a particular set of things will appear. Perhaps not like this, because I have already signed in. So something will look like something like this will open up, and make sure that you're already signed in using your Gmail account, your Google account. Then simply go to File and go to New Notebook. And then what you'll be able to do is open a online Jupyter notebook in which you can actually run AstroPy, NumPy, Pandas, or any other different library that you weren't able to import in that online Jupyter notebook, which was suggested earlier, right? So that's one method in which you can do this with using Google Colab. Okay, so you just need to search for Google Colab online and go to the very first link. Okay, so that's the head start. Okay, so now moving on forward, we simply have to first import this pandas library, which is called import pandas. Just simply import pandas, or you can give it some alias. Let's say import pandas as PD. So PD is one of the mostly used convention for calling this particular library panda. So I'll just import the library, and I will go data is equals to pd dot read underscore csv. So this particular library has a function called read underscore csv, what it does is it reads the file in that CSV format, right? There's a particular format known as CSV, and a type of CSV file which contains nothing but tables and some assorted data which you have. So what you can do is you can call this function and input the file destination where exactly your file is present. For in my case, it is present in some folder, and then I'll put up. Uh, um, so it's like I just need to see that how my data types are, how my columns are being separated, right? How my columns are being separated from one column to another. So I see that it's actually separated by some space, and sometimes that space is not exactly just one space. Sometimes it's a tabular space, and sometimes it's two or three spaces. So that's why you will see that when I simply put data is equal to this, I run this thing and I see what type of data I have. So it shows me these types of columns, and you will see that all have been read already. First column shows nan values. Nan means sort of none values. Okay, you can just simply say that there's nothing in that. It's totally no values in this particular cell. So first column is this nan. Second column, which is referred to as one, it has date. Second column has time. Third, fourth, fifth, sixth, these all are actually spaces. The spaces which have been filled up with some nan values, which means no values. Seventh is this 20, as I'm sure these must be right ascension values. 7, 8, 9 right ascension. uh, I need 20 degrees, 3 minutes, and 51.65 seconds, right? So that's my right ascension, and then that's declination. Okay, and this 17 and 18, no need to worry about those values. So this is basically the Jupyter's I guess Saturn and Jupiter conjunction values, meaning that in our sky, what exactly is the coordinate of Jupiter on these particular dates and at this particular time. So that's what has been taken. This data has been taken from, I guess, NASA Fermis data, and I can maybe show it where exactly this data has been taken from. Maybe ma'am can share this link.
Actually, this was done in one of the sessions,
Yeah,
so
yeah.
I can do it later on. You go ahead.
Okay, no issues. Okay, no issues. So this file will be given to him afterwards, so no issues. So what we have to do is we have to simply just read this file. How this file is separated, I'll just give a separator, which has to be given in the quotes. Okay, just always remind that it will always be in quotes. Okay, so in quotes I've given a simple space. Okay, a simple space, not a tabular space. Okay, a tabular space looks something like what? It's more like this, right? It's not a tabular space, it's just simple. Oh, sorry, tabular space, you can give it like /t. Okay, that's tabular space. but now it's just separated by single space, and that's why I've written this. And you see that there is one time one once there's this single space. Sometimes there are more than one spaces. Okay, you see this is 4. So if I change the number of simple tabs, you see that how its value is stored. In one column, you get date and time. Okay, if I have the separation of the columns as two spaces, so that sometimes happens. So you just have to take a single column and it will give you a much better look at the data sets, right? So how do I call different columns? Now also remember that my data has no header. For those who doesn't know what header means, so header is basically a set of some text, some ASCII data, some ASCII format some data in the format of ASCII, which tells us about that type of data. Okay, sometimes it might have different coordinates, it might have the source name, it might have from where it was taken, etc., etc. Some data set which is not required in our analysis. I mean, in our whole data analysis, but just the basic information about the data, right? So this is header. So our data does not have any header, so I will just give it none. So if I do not give my header none, okay, it will take that there is some there will be some header. So by default it considers that our data already has some header. So if I do that and I don't give any arguments for header, what you'll see is that it has taken the very first row as the header, right? You see it has taken the first row as the header. So we'll just put a header as none. And now you see that it has indexed the numbers as rows and columns. So if I want to access the date column, okay, like this first one, this is my date column. So what I'll do is I'll just see what column number it's 1. So I'll just put a 1, and here I have dates access to it, right? So if I want to access, let's say, one particular value, let's say that first this 0th one, so I'll just put up another square bracket, which will give me the what row I want to have, which is the 0th first value. It will give me the first value. Let's say I want the 100th value. It will give me 100th value. Let's say I want 1000, but there are no 1000th value because it just have some particular set of columns around 300 something. So it will give me an error that there is key error, which is 1000, which means that there is uh, no row with 1000 index. Okay, it just have some 300 something like that. You'll see, yeah, some 313 rows. So the maximum that you can get is 313. Mm, no, not 313, but 312. Why? Because the counting starts from 0. So 0th will be the first value, and 312 will be the 313th value, right? So this is how it will give me. Okay, so this is my whole data. I can save my time. Let's say dates. I can save my dates as, let's say this is the first column. Time, I can save as data. You can see the second column. I'll just put 2. Then I have, let's say, write ascension. Now, write ascension is given me in 23 and 51.65. So if you have already done the conversion of write ascension and declination, so what I'll do is, first it takes the first value, which is this 20, which is 7, plus data, which is 8th, which is the degree. I'll just divide it by 60, plus data 6, 7, and okay, 7, 8, and what we have is 9. I'll just divide it by 3600, right? So it will give me totally in the degrees format, right? This whole array will be in the degrees. And declination, you can just simply do data. I have 10, then I have data. I have an 11. Okay, same thing, which will be in hours, minutes, and seconds, and 12, which will be divided by 3600. Okay. So now I have successfully imported some data sets, which includes array and deck, right? This is my array and deck. So you can simply plot some format, let's say plt.plot. I can plot array versus deck. I mean, just to see what particular format I have. I haven't imported the library. So you see the error is matplotlib does not has any attribute as plt. So maybe I have forgotten something. So I have to import, let's say I'll just import the library. Okay, and I will go again, plt.plot. So I'll just see that array versus deck, it gives me a straight line. Or instead of this, I'll just do scatter. Scatter is a much better option, which will tell me that where exactly is this um, position going on. Size, let's say 10, let's say 1. Okay, so it's most likely like it's just going down and down and down and down, right? So this is how my whole array is changing, right? With right ascension is changing with declination. Now I have this so I have one exercise for you, which I guess it would be better that if you can try to do it, and which is exactly is plotting this dates, so the dates that I have, you see here, so dates are actually saved like this. I can create it as list. Creating it as list is simply just put list. It created some list, and it will have just nothing but a series of string numbers. So this is actually converting it into strings, right? So what I need is I need to convert this whole thing into some particular format, which may be, let's say, mm, okay, I can give it any date. Okay, it's totally up to me. If I want, I can give it, let's say, I can convert it into different format. Let's say right now it's actually in 2020 December 15. So it's more like in the format of year, then it's month, right? And then it's basically date, right? This is also, let's say, date. So you have to convert it into, let's say, 0 year slash month slash day and stuff like that. You can basically convert from one data format to another data format. You can use another library which is called date time, and date time has different sort of functions. Let's say date time dot date. Okay, it can actually convert from one particular um, you know one particular format. So okay, so one exercise will be for you, I think, which would be better if you can try to do it, is first try to interpret the date time column. So right now this dates, if I see, if I don't use this particular thing, if I just see what exactly this particular thing is, dates. So if I just do a type, I see it's a series of data. And if I, let's say, okay, let's do that. Let's make it a list, in which is a much preferable format for us to work with. And I see that what's the type of my dates. I mean, what type of data it is. See, it's list. And if I just simply put it, I see that it's actually strings in the data time, right? You see this, these are strings. So basically we cannot print strings, I mean, that's an issue. So first we have to do is basically convert this thing into a readable format. So what you can do is you can use this library, this date time library, and you can use a function, let's say date. And what you can do is you can simply convert, uh, sorry, okay, date time dot date. So you can convert this particular date into a particular date object, right? So you can simply supply year, month, and day from this thing. Let's say if I, let's say my first value is date 0, and I want this year. Okay, I want this particular year. So what I'll do is year is equals to, so I'm just talking about just one row. So year, which has basically this 4 things. So it is from 0 to 4. Okay, slicing, I hope you have already done that. So year can be saved into this thing, and if I just put it here, I get 2020, right? But as you see that it's actually enclosed in some quotes, this means that it's a string. I want it into the integer form, so I can simply write it as int.
Slicing hasn't been done, but I will upload some Fossey videos which talk about slicing.
Oh, okay, I
Suppose
think,
that probably people can use it. Hmm?
okay, I think
So
it's
I will
already.
do that.
I'll just
There is a question also, Saurabh. Prajwal is asking, without Xammp server, how is your local host running?
sorry. Let me just see this. Um,
Mm, Prajwal is asking,
mhm. Let's see. I don't know what exactly to do with that, but basically my I simply run it on my my whole Mac. I mean, I just have this particular notebook which I've installed in my laptop, and I simply ran that. I mean. There's no need for that, something like that. It basically runs on itself, you know. I don't need a server. It's actually just being installed. You just simply, so let's say if you are, let's say if you have a terminal, okay, if you're working on some Linux or you're working on some, let's say, a Unix based system. So mine is a Mac. So what I do is I just simply type Jupyter Notebook because my system has already installed Jupyter Notebook, right? If you want to install a Jupyter Notebook, you can give some simple commands, which is pip install Jupyter / Python 3, something like that. Okay, I don't exactly remember the command. So you can simply use something like this command to basically install Jupyter Notebook, right? And you just have to give it a command, let's say Jupyter Notebook, and it will open up on my local server. So it will be just working on my local. Okay, I'm just working locally on a whole machine, right? So that's how it's working. It isn't. It's not like a server, something kind of thing which works with networks or something like that. But it's just a very local thing. Also, I do not understand what exactly is Xammp server, so uh, yeah, I mean it's fine, I guess you can work with this. Okay, so okay, where was I? Okay, I was telling about slicing. Slicing is an important aspect of as you understand by the name, slicing is basically slicing your data sets, right? Let's say I have some data. Okay, I'll just begin with this thing. Let's say when I have some data. Okay, let me just make this a bit more clear. Okay, now let's say I have some data. Let's say 0, 1, 2, 3, let's say 6, let's say 50. Just giving it some random values. Okay. Now, if I put 0, okay, this means I'm giving it some index. So 0 is the index which I'm giving in this thing. So what it will give me is the value at this index. Okay, 0. So 0, if I put in here, it will give me 0 because in 0 it's 0. If I put it data equals to 10 and I put the 0th part, it will give me 10, right? If I put it, let's say 3, it give me 6, right? This is how the index works. Now let's say I want values from 1 to 3. I want from 0 to, oh sorry, from 1 to 3. Okay, I want these three values. So what I'll do is I take 0 to 2. Okay, this means from 0 to 2. Okay, so it will give me 10 and 1, which means this and this. And also it does not add up, it does not give me the final value. So from 0 to 2 we have only two things, 0 and 1. It does not count the third part. Okay, let's say if I have 4, 5, so it won't take the fifth thing. Okay, it will just take 0 to 0, 1, 2, 3. Okay, it won't count the last, it won't add up the last number. So I'll have 0, 1, 2, 3, which is 0, 1, 2, 3, 4. Sorry, 5. So it's 4. So it's this thing. Okay, counting always starts from 0, so you have to be aware of that, right? Let's say if I want these, only these 1, 3 and 6, which is 0 to, oh sorry, which means second, third and fourth values. In terms of Python, it's almost -1. So what I have is 0, 1, which means 1, 2. Let's say I want 1, 3, 6. So I'll give it 1, this is 0, this is 1, this is 2, this is 3. So I'll give it 4. It will be +1 and it will give me 1, 3, 6. A very simple thing. This is called slicing. Let's say I want all the values. Let's say I don't want to have this particular 10. I just have to be this values. Okay, I just want all these values except 10. So what I will give a very simple command is this. Sorry, this, which means from 1 onwards. This actually means from 1 onwards. Let's say I don't want to include last value, so I'll just replace this thing with this. -1 means the last value. So let's say if I have -1, okay, I have -1. -1 basically means the last value. Okay, I can't write it -0 because there is no such thing as -0. What we have is just -1. So -1 is basically the last value. So let's say I want all the values up to this, but not the last value. So what I'll have is expression something like this. Okay, this is basic slicing. You can just do it like this. Let's say I want 2 to 3, 4, 4 to -1. Well, let's say 1 to -1. This means I don't want to include first and last. like this. Sorry. So I haven't included the first and last, and what I have is the middle values. I hope I'm clear. I hope everyone is understanding what I'm trying to say. If there are any questions, I'll be happy to take up right now. Are there any questions?
No, not just
Let me
now.
just. Okay,
Not just now.
great. So yeah, these are just a few values that we have to take up. So this is called basic slicing. So here, what happens is that when I'm talking about dates 0 means the first row. Now 0 to 4 means now I'm taking the values of this whole thing, right? So if I talk about this, let's say I'm talking about dates and I want this. 0 means the very first column, and I'm writing slicing it, which means what I'm taking is I'm counting independent. I'm counting independently these values. Okay, this values. So I want from 0 to just count it 1, 2, 3, 4. So I just wanted 0 to 4, which means including 2020. Let's say I counted 5. So what I have is the hyphen as well. Okay, so you just have to have the 4. Now I have this 4. I converted that into the integer object. I told it in the very first session, in the yesterday's session, that we have different types of data types. We have integer, we have float, we have string. Okay, so I want it into the integer format. Obviously, because dates are not considered into the float thing. You don't have decimal placed year, right? 2020.1. No, we have 2020. So I'll just put it in integers. Okay, now let's say I put it 5. Okay, and what happens? I'll just see that what exactly happens if I include this hyphen. So it says an invalid literal for int with base 10 because I have this minus this hyphen included. So hyphen cannot be converted into an integer object, right? Hyphen is just a symbol, so it cannot be converted into that thing. So I just have to have 4. So it will just convert the year into that particular thing. Okay. Now let's say, okay, this was about the year thing. You can convert, let's say, months. Okay, let's say month. So month is just a string thing. So you can just convert this string. Let's say I don't need it because it's already in string. So dates equal to 0. Let's say, okay, dates 0. Now month is basically, you see, so 0, 1, 2, 3, 4. 4 is 2020. 5 is this hyphen, then 6, 7, 8. Now I have 6, 7, 8. So I just simply have to do this thing, 6 to 8. Now, as I told you that if whatever the final values, it does not include that, so I have to do a plus 1. So what I have is 5 to 8. So what it did is it counted me this thing 5, 6, 7, and then this particular thing. So it had to be plus 1. So that means that it does not include the final value, not the 8, but till 7. So that's the month, right? So just have to do something like this. Date, which will be 5 to 8. Okay, same thing goes with the day part, which is dates, and yes, it will be an integer. The dates, same goes with the 0 part, and then I have okay, so this is 8. Now it will be from 8 till 1, so 8 till 10, right? This will be 9 till 11. 0, 1, 2, 3, 4, 5, 6, 7. This is 8, and then this is 9, and this is 10, and then 11. So the final value is not counted, so we have this thing. So now we have done for the dates as well, and that's how we have done for the slicing for the first date. So let's see. I have year, I have month, and I have day. Now this is just for just look at this. This is just for one particular date. This is just for one particular date. Let's say I want to run it in the loop and do it for the all the columns, right? So this is my first. This is my first index. This is my first index. Let's say I want it for 100th value. So I'll just simply do the 100, and it will give me December 2019. But I want to do it for the all the columns. All the columns. So what I'll do is I'll try to use a loop. Okay, I guess you haven't already used a loop. Ma'am, were there any loops in the FOSSEE lectures? If they have already done that?
No, 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 not done yet. Uh, Uh, when perhaps maybe one example may have had come, but
Okay.
not done in. But I will be. You just go ahead with your example, and I'm going to be uploading the Fossey talks which talk about all of these. So
Okay.
just explain for your example. That's enough.
Okay. 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 So how will I do it? I'll first create an empty list, a list which is empty, which has no values. Year, day, year, month, then I have day, like this. This is an empty list. Now I'll use a for loop. So for I in, so I want to create a loop for each and every file. Okay, so I want to run the loop for all these values. So for that I need to count how many values are there. Now yesterday I told you a very simple function inbuilt in Python which tells me how many values are there in the whole list or an array. What I have to do is just to type len, which means lengths of dates, and it will give me 313. Okay, and there is another function. What it does is basically generates values from your starting point till initial point. Okay, and giving just a space of one, 1 2 3 4 5 6 7 8. So as I told you that this particular zero means the first thing, one means second, and then two means third, and so on and so on. So this only takes up, this index takes up only integer values. So I just want a list of integers to be made. So there's a function called range here, which what it does is if I supply it, let's say I just give it 10. So what it does, it actually creates a range of values from 0 to 10. Okay, it does not, it actually creates a function, but let's say if I print all the values of 10, I'll have to use a loop to print all the values in this particular thing. Okay, let's say, just to give an example, let's say L is equals to range 0 to 10, or let's say just 10. It automatically takes from 0. So using a for loop is very, very simple. Just type for I in L print L. So just explaining what this works is we first have to run this code and then see. Hmm, sorry, I. Okay. So what this means is that I've saved all the ranges. I've set all the values of range in this particular data type, which is in this variable called L. Then I indexed all these values as some I. Okay, there is some, I have indexed all the values. This means that I have labeled all the values with some particular numbers. So first value will be the 0, second value will be 1, 2, 3, and so on and so on. So each and every value has been indexed. So this means I'm indexing all the values in L, and then what I'm doing is I'm printing those values at that particular index. Okay, so like this. So it's printing me all the values. A very simple usage of for function. Let's say instead of this range I use numpy function. I can even use numpy function, but be aware that it's actually using what it's actually using float value. So it create four float values. Okay, I use numpy this like this, and it gives me these values. It gave me a total of 10 values. Okay, between 0 to 10. Now length space, what length space does is it actually includes the final value as well. So that's why there are total of 11 values. So that's what we need to do, is we have to create total of 11 values, and that's how it's giving me equal space of 1. But it's creating, see, it's creating a float value. We don't want that, right? We don't want that because it won't take into this index column. I just want integers. So I just have to use range. Okay, very simple thing, very, very simple. Now I know what is the length. So uh, length equals to length of how much? Okay, dates. This is the length. So for I in range of length, right? Instead of saving this into another variable, I just wrote it directly, which is just to reduce the line number of lines of the code. Now what I'll do is I created an empty list. So how to append my characters into the list? I don't know that if you have already done that. Ma'am, have you done this appending thing or not? I mean, it was there in the
No, it was
Fossey
not done.
video.
It is there in the fossil lectures though. but
Okay, I
I
will get.
don't think
Okay,
it was done in our sessions.
okay, no issues. So I'll just explain the appending thing. So what append does, append is just simple English word, which means that it simply puts some things up there. Okay, so let's say I have this year dot append. Now, whatever I write inside this thing, it will add it up in this particular list. A simple example to show how this works. Let's say I have a list of things. Let's say L, 1, 2, 3. Okay. Now let's say I want to add a particular let's say I want to add some element to this particular thing. Okay? I want to add element, let's say 5. So what I'll do is I'll simply do L dot append and I'll name this particular element, let's say 4. Okay, it appended this 4 into this particular list. Now let me see that if my element has is there. Okay, my element is there, right? A very, very simple and uh, very basic approach to adding up elements. Now that's what we are doing. Let's say I created an empty list. Empty means it's nothing, it does not have anything. Okay, if you have studied, let's say, the sets and the relations in your 12th standard, or even in your 11th standard, you must have come through sets, groups, something like that, right? So it's something like, you can consider this something like that itself. So I have this set which is nothing, just an empty set, or let's say an empty list. I am putting some particular value, let's say 5, and let's print my L. So my L is 5. Okay, it was an empty, it does not have, it doesn't have, did not have anything. Now I just have some particular value which is L. So this is what I'm doing with my whole function in here. I'm appending my all the values of dates into this empty list. So here dot append. Now here I've already done that, right? I'll just copy this thing, which makes it not this one, sorry, yeah, this one. Okay, I'll just do this thing. I will change this this thing, this one. Let's make it Y. Let's make it M. Let's make it T. Okay. Now year is this, date is this. Now, as I told you that the very first thing, this very first index is how, which particular value I want, right? This is which is what particular value I want. So if I put it 1, this means second value. Okay. So in this thing, I will run the whole loop. So instead of 0, this means that this whole thing is changing from where 0 to 313, right? 0 to 313. So this means that this is the thing where I will be changing, inputting my, I'll be inputting my loop. Okay, so here's where all the loop will be working. And now I'll just have to do which is y dot append. This will be here. Then m dot append, which will be month. Day dot append, which will be d. Oh, sorry, it will be d dot append and day. Okay, and done. Now let's see if it worked. Okay, all the year are here. Now all my months are there or not? I have months as well. It is starting from November, I guess. Okay, no, it's starting from December. Okay, days are changing maybe. So 21, 22, 23, 24, 25, 26, and till 28. Okay, right? So I hope this is clear. So what I've done here, I'm explaining this once again. What I've done here is basically I've chosen a particular format that where exactly my year is stored, where exactly my date is stored, a month is stored, and where exactly is my day is stored. I ran a whole loop through it by using this particular thing, by using a loop on the index. Okay, you see every time the index is changing. So where the thing is changing, I'll input my loop there, which is I. And if for your convenience, if you want, I can print what I is it taking, and you see. So every I, it's just taking 0. So this means dates 0. Just put it 0 here and it will do the whole step. Now, one important thing of programming here, that how you do programming is basically doing it on your pen and let's take a pen and paper and just try to apply this whole thing on pen and paper. Okay, that's a this is a very basic thing to check that what exactly your program is doing. Program only works what exactly you are supplying. Okay, it just works whatever you are giving the program to run. It does not do anything by itself. Okay, it's actually dependent on you, what as a user you are supplying the computer to do, right? This is the very basic thing. So what you
Uh,
have to do is,
yeah. Sorry to interrupt, Saurabh.
Mhm.
You mentioned the collab, right?
Uh,
So giving information to the program as to where your data file is. At least I am running into trouble, and maybe some of the others may also.
in Google
Like when you
Collab.
are in the Jupyter notebook, or if you are suppose in Collab notebook,
Okay.
and you have this program written, and then you need
Okay.
to access the file. You had a statement for read the file,
Mm-hmm.
but then again the way you are set up may be different.
No,
So
so this
yeah,
is my actually directory. This is my directory where my whole file is saved. Okay. It actually varies
in your
from between
system.
different systems. Yeah. Yeah, this is in my
Acha,
system. I'm working in my
when I
system
give
currently.
that, huh? But when we are using online collab,
So
what do we
what you have
do?
to do is you have to actually upload it here. I guess there will be, yeah. So here you may have to upload your uh I guess there'll be some option of library. Yeah. I guess
Yes,
maybe
yes,
have
there is
to.
an option, and I have actually uploaded, and it
Okay.
also shows a drive,
Okay.
and I give the drive का जो भी URL है,
So
and then
you
I give
know.
the file name, but it still is running into trouble. Okay, these are the detailed problems. We will probably have to sort it
Okay. Okay.
separately, not as
Okay.
part
No
of the
issues. No
lecture.
issues.
Please go ahead.
Okay. Sure. So, okay, okay. So I was telling how to basically debug your code or how to basically check your code that what exactly your code is running is just doing it by hand. Okay, just take a pen and paper and see line by line what exactly your code is doing. Okay, so if I check this line for I in range, so it's actually trying to start a loop on this range where length is basically 313. Okay, I told you this thing, and it generating the numbers between this two particular thing, and it's doing one by one. Okay, and it's printing these values. So I print these values from 0 to, you can see it here, 312. So this is total of 313 values. Just remember that because it's counting starts from 0. Then every time this my list is changing, it is doing from 0 to 1 to 3 to 4 to 5 and stuff like that, which means what type of value I want to access and what cell I want to access based on the index, which is actually continuously changing. So that I have to put it up in loop. That's what I is for. And then append means I'm just adding whatever the value I'm getting here to this particular thing, right? And to make it much more easier, what I mean here is basically it's generating just one value. So let's say if I do not have any loop, so I just ran this thing, right here I did run it somewhere here. Okay, it's not here maybe. So what does it mean that it's actually just doing one loop? Okay, this just means that it's just generating one value. So every time a loop runs, it just does one value. So that's why I have to run it multiple times to access all the values present in my data set. And that's how it's done. So I'll just do it like this. And I have done my date, time, and whole month thing. Okay. So that's how you can basically access your whole thing. And for the conjunction thing, I think you just have to access your whole array and deck, and then on that basis you can basically check your whole thing. And same goes for the time thing. Okay, so this is exactly the same thing. I guess if date has been done, maybe you can even try putting time uh, in your thing. Maybe it would be easier if you can try to do this thing by yourself. I hope you'll be able to do that. I guess so. I do hope. But so yeah, that was about date and time. I hope everyone is clear about this thing, and then maybe we can move forward with today's session, and a second session of this part. Are there any questions still here? Any questions?
No, no, none right now. None
Okay.
right now. You can
Okay.
go ahead.
Okay, so moving ahead, the second part is basically curve fit. What I call, what people say is linear fit or simple curve fitting. And what exactly does it mean is, let's say you have some observational data. And yesterday I talked about how we basically do in astronomy or any other sciences, how we try to model something. Modeling means if I want to see what type of behavior it would follow till the future, or what type of behavior it followed in the past. Okay, this is my whole theory and I want to test my theory. So to test my theory, what I have to do is I have to see that whether my model is fitting the observational data or not, right? Let's talk about, if we're talking about, let's say, galactic rotation, and I want to see if this dark matter profile, right? If you have seen that how the radial velocities of stars at the edge of the galaxy are changing, right? There's some spike and then it goes on increasing and increasing and stuff like that happens, right? So if I want to check whether my model is trying to explain or that or not, I will try to fit my data. So that fitting has different modern techniques that we use, and these techniques are called numerical methods. So these numerical methods are basically some mathematical methods which are actually made very let's say in a form of algorithm which computer can understand. Okay, so one of those methods is called least square method, which what it does is it tries to minimize the errors. Okay, minimize the errors of my whole uh, whatever the whatever the function I have in order to get the best values. Okay, a simple example if I would like to show in here. Okay, I will explain the code later maybe and just tell you how to do this stuff. Let's say, mm, okay, I'll explain it once again, but first I'll just show you what exactly I mean if I by when I say a straight line curve fitting. Okay, so what I mean here is, let's say I have some data sets, okay, which means like stuff like these. So this plus thing, this is my, let's say, some data sets. Okay, I did some experiment, this is what the data I got. Now from my, let's say, my theory suggests that this data set should follow a straight line, right? My model says this is my theory. Okay, I hypothesize something based on my all the stuff, and I theorize it using my mathematical techniques that this data set should follow a straight line. So how would I try to see that? Okay, so what model would fit better with what particular values? So let's say I have this data set. So using all the numerical techniques, using which I say as curve fitting, which I say as curve fitting. Okay, this curve fitting, I found that this is the model which fits my data in a better way. Okay, this is my whole data set, blue part, and uh, this straight line is my model. Okay, with that particular set of value. So this is what exactly I mean by model fitting. Now you might say that, okay, okay, you have done this, but it does not look like a straight line. Yes, my data does not look like a straight line, and this would suggest that my model might not be a correct model to explain this observation. Either this is the reason. Second reason, it could be that the errors in the observation are so much that my modeling is not trying to work in a better way. Okay, this is my second maybe not sort of conclusion that I can give on this numerical analysis technique or my data analysis technique. Either my model is not working correctly, or the errors that I have in my observation are too large to basically fit my whole thing, to fit my whole model. So how to do a simple curve fitting or simple linear linear fitting? Basically, what I say is model fitting. uh, we use a function of a library called SciPy. Okay, SciPy is another very important library, um, which is used for scientific analysis. So I'll import a function called curve_fit, which does all the technique, all the algorithms in the background. And I won't explain out what algorithm they use because this might go out of the scope of this very introductory thing. But for those who have already done this thing in your undergraduate levels in numerical methods, whole section, whole coursework, then you might understand the least square method, or let's say non-linear curve methods, non-linear curve fitting methods, and all that stuff. You might understand that. So this is just an implementation of that whole thing. Okay, so I have this scipy.optimas thing, and I import my function from this library. Okay, I imported curve_fit. Next step is to make my model. Okay, so this is my whole model. Let's say my whole model is a straight line. So defining a function is very simple, as I told yesterday. Just do a def, then space, then the name of the whole function, then brackets, the parameters on which your model is dependent. Okay, let's say my model is dependent on the values that it should take. Then there is the slope for those who have already understood, or who have already gone through the basic equation of a straight line. So basic equation of a straight line is nothing but uh, mm, is this. Let me just type it down for you. So a basic thing is basically y is equals to mx plus c. This is my whole uh, straight line. Okay, this is my straight line equation. Okay, so I'll do the same thing. So y is equals to mx m star x plus c. This is my model. Okay, and I'll do it y. Okay, it is, then I have to return that what exactly this function is returning. Okay, this is returning y. So I've returned it y. Right. The next thing is basically I want to generate some values. Now I want to generate some fake observations. Okay, either you have some observations yourself. Let's, okay, that would be a nice thing to do. No, maybe not that, maybe not that. So no issues. So let's say I have some observational data set which I've already imported in my Python. Okay, and I want to work with them. So for now I do not have any data set. Maybe later on we can use some data sets, some different type of data sets of different models. But for now, let's say I'm simulating some data sets. Okay, some random thing. So what I do is I generated some values, let's say from 5 to 15, generating random values. Okay, not random, but some values with some particular intervals. As I told you about this function linspace. So I'm generating some values. Let's say x is equal to np.linspace from 5 to 15 till how many numbers I want? I want 50. So if you don't want, you cannot write. You don't need to write this thing. Okay, it can work like this itself. So let's say I've generated this value. Okay, and let's say this is okay, let's say I want to generate some values, and the basic observation will be y, and y will follow this straight line. Okay, something like y. Okay, I'll just do this stuff. Okay, and let's plot this. Now if I use this my model to generated some fake values, it generated like this. Let's say I want to add some noise means there is some abruption in my, let's say there is some in my observation. Whenever I try to observe something or whenever I try to experiment something, there will be obviously some errors. It might be instrumental errors, it might be human errors, or it might be something entirely which you do not understand. Okay, so let's have some errors induced in this particular thing. What I can use, I can create some random values. Okay, I generated some random values, let's say from a function which is called random. Okay, random dot normal function. So this is okay, normal means it is actually generating values from a normal distribution. So for those who already understand, undergraduates, they know that what exactly normal distribution means. For those who do not understand, okay, normal distribution is nothing but a set of values who are actually peaking on to some one particular value. Okay, it's giving me sort of a bell curved shape. No need to worry about that. You just need to understand this is just generating some random values. Right, now I added my noise, or let's say some errors to my original data sets. Okay, so y equals to y plus noise. So y is here, model plus noise, and I've got some noise added up in my data set. And now let's see how it's working. Okay, now I see how it's added up, and it's not following a straight line anyway. Right, this is how my observation works. So this is my observation. Okay, this is my final observation. Let's name it as observation. Okay, observation. Okay, this is my observation. Now what I'll do is I'll call my function, which is curve underscore fit, which is a scipy function. The first argument that it takes is my model. Okay, the model that I have taken. Okay, second, it takes the input. What I have is the x value and the y value. So x data is basically x, y data is basically this observation. Right, I have this observation. So y data is observation p0. So p0 is basically a list of those values which are your initial guess. Initial guess of what your model would best fit. You know, so our main motive. So the main motive of our whole stuff is to find those set of values of m and c which would follow my which would follow this particular data set. Okay, this is my whole motive. To make it much more specific, I need specific values of m and c such that I can generate a straight line using this equation to follow this data set. Right, so this is the initial guesses that I'm giving of this whole curve fit function. That, okay, this is my initial guess. Let's put m and c equals to
Oops.
0.
Can I just interrupt for a minute? Saurabh, there is a
Yeah,
question.
Yeah, sure.
Prajwal is asking, can we import data from a MySQL database for using them in Python? Must be,
Yes,
right?
yes, yes.
Uh-huh.
Definitely. I mean, it's totally up to you, whatever data set you want to use. I mean, I personally haven't used MySQL right now, so I cannot tell what type of things you can do with that, but definitely you can input any type of observation from anywhere, right? So you just have to import your data set, whatever data set you already have, okay, and then you can simply use that. So let's say I have observation and okay, so P naught, which is P0, which means my initial guesses. So let's like have a look at the function, that what type of function this is. Let's put it. So okay, now here it explains it. So f is the model function which I have. Okay, x data is the x values, y data is the y set of values, p naught is the initial guesses for the parameters. Okay, sigma is the error and all that stuff. I won't put up this whole thing. Okay, then I guess there will be some different arguments as well, which means that what type of method you want to use to calculate your whole values. Now it generates it returns two values. One is POPT and one is PCOV. So POPT is nothing but the parameters that I have, the values that I want for the best estimation. Peak COV is the covariance matrix, which means the standard deviation, which means a particular set of values, which is covariance matrix. And to explain it, you mean I can say it basically it tells me um, what would be the standard deviation, which means how much my error will deviate from my normal from my whole estimated values. So that's the covariance matrix. You don't need to worry about that uh, right now. I'll explain it. So this is the curve fit function. I'll just run it. Okay, I ran it. Now let me see that what values I got from it. Okay, so for first, which is you see here is m, I got 0.4622. This is the best fit value that I got, right? And for another thing, I got 1.5969, something like this. Now, what you see here is I actually I actually found the best fit values using my observation. Now, I created a fake observation using my whole model function. So you see the original value that I used, zero point 0.5, I almost got back something like that. I almost got back, but due to the error, which is very large in this thing, I did not get exactly zero point 0.5. Okay, I got somewhat around 0.46. But another catch is here. Initially, when I put intercept to be zero point 0.5, now I got intercept to be 1.15, which is quite large. So you see how how a difference you can have in this error, in this whole error thing, right? This is just a basic stuff that I wanted to mention, right? This is how you got the values. Now to find that how may okay, I won't explain this for the now. For this step, I'll explain it later on. Okay, so now here what I'll do is let's say okay, so now I want to see that what is my model thing. Okay, I'll just okay, so this is my whole starting model, right? This is my whole observation. Sorry, this is not the observation, this is my observation. Okay, this is my observation. I use plt.scatter to find the observation. Now I want to find that what exactly is the best model that I got. So as I told you that pars is is containing those values which I already have. So the value of m that I got is 0.4622. The value of c that I got is this. So now I want to generate. Now I will generate the model. Okay, now I will generate the model. How I will generate it? It's very simple. It's like this is my whole model thing. Okay, so let's say model equals to okay, model equals to straight, sorry, so let's say best fit model equals to model. I already had the values of x, right? I call it x because I already generated the value of x. Then I want m and c. So m and c I told you. So if you see here the parse, so this is actually a list. Okay, so if you want to access the values of let's say first value you want to access, you will have it 0, which give you the first value. Parse 1 will give you the second values. Okay, so I have this 0, then I have 1. This gave me this thing. Now let's plot this thing. I have x, then I have best underscore fit underscore model. Okay, now this is my best curve fit model. Let's see that how this is following my observational data set. So let's color it. Let's say okay, let's color it. What? Let's color it red. Okay, and let's make it plot. Okay. So you see, I have got a straight line which is following almost all the data points, almost all the data points. And this is the curve fit that I got. So this is called a linear curve fitting. It is one of the very important aspects in science and especially in astronomy. If you want to get into data analysis or if you want to go for, higher stuff. So where do we use this stuff is like you use in cosmology. We have different models of in cosmology to understand redshift, to understand how the universe is expanding, to understand the baryon distribution of the matter baryonic distribution of our universe and all that stuff. So I want to estimate how much is the distribution is we have of that stuff in our universe. So I have observations from different satellites. Let's say Pantheon data. We have some from Planck data. I use that. I construct my own model. I do stuff like this. Although this is a very basic version of curve fit, we use much more sophisticated methods to analyze parameters in astronomy. But this is the very basic stuff that what astronomers do. Okay, this is what we call as curve fit. So we do this, and voila, we have the whole stuff. I hope I'm able to reach out and you're able to understand what I'm trying to say. If there are any issues, I'd like to have them now, or even if you want me to explain it again. Ma'am, your voice is again getting very fast forward. Maybe there's some issue. Ma'am, I'm not able to hear clearly. Maybe you can join again. Okay, ma'am is saying no questions as of now. Okay. Well,
All
I
right,
guess
please.
if
Is
you
it
have
any
any,
better now? Is it any
yeah,
better now?
now, yeah, now we can hear you.
Oh, that was wonderful, Saurabh.
Hmm.
And so I am just thinking that perhaps we, for this series, we stick to only linear fit. And maybe
Yes,
the
yes, yes.
next
That,
series, when we have, we will start with non-linear fit. And
yeah,
when
yeah, sure.
everybody has caught up with this.
Hmm.
So I don't see questions as of now.
Okay.
But perhaps, I mean, people, when they get started doing it, they may
Hmm.
run into troubles like I did. I ran
Hmm.
into trouble just at the read stage of this
Okay.
Full. So,
Maybe.
anyway, so we will all try and sort those problems as we go along. And I want
Hmm.
that everyone does complete. Did you give any homework assignment? Maybe you should do
Maybe
that.
I can give.
Do
What I
that.
can
Do
do
that.
is
Yeah.
let me just share my screen. Okay. So the one thing that you can try here, you can try to import some data set. Let's say you can have some data set, or maybe what I can do is I can generate some data set for you guys. And what you can do is you can try this simple curve fit, right? You can do this once again. And okay, what I think will be an appropriate thing is I'll share this notebook, maybe for
You
the
can
reference
share.
thing.
You can share the data in the groups,
Okay.
and but the problem that you want people to solve, you mention it here.
Okay, so what I think is what you can try to change this model. Maybe let's say I want my model to be of x square. Okay, so if I see I have a model something like this, and now I will give you some data, you can do that. But for now, it would be best to have just a linear curve fit, which means a straight line curve fit. Okay, and I'll generate some data for you, and you have to do a simple curve fit like this. Okay, you can change the initial guesses as well to have some better, some what, some better constraints for the whole thing, and like this. Okay, you see how my value actually changed, how the line actually changed. So this is the thing. So so what I will do is I will create a Jupyter notebook for you people, in which I'll mention what exactly will be the question of this thing, okay, and what you need to solve for it, right? I will mention the entire detail. That would be, I guess, a better option, better thing to do. I guess maybe,
Okay.
because many
All
of you
right.
people are not present here. So I'll create a Jupyter notebook, an empty Jupyter notebook with no codes, but just the exercise that you will guys need to do.
Perhaps some of the things which were done here, one or two of those lines could be there in your Jupyter notebook.
Maybe, yeah, sure. Okay.
Some
I
things
will explain the
like
process.
whatever you did for. Acha, you are done one linear fit and you are giving another exercise in linear fit only. No, so
Yeah,
okay,
or maybe
don't put all the solutions, but
no,
at least one or two
I
things
won't
to
be
begin.
I won't be putting up the codes. What I'll be doing is I'll just simply give you an empty notebook, with no codes, but just the exercise what you need to do. Perhaps maybe I can give you the procedure how you want to do that, but not exactly the whole code. That then you can try to do that on yourself.
Okay. Advai is asking, did we do the pendulum program? So
Mm,
the pendulum one is actually part of the fossil lectures, and I have actually shared the pendulum data, and I'm going to share the relevant video in the drive soon. Okay, what you need to do, because
mhm,
that is I have not given that corresponding information to Saurabh yet. So
mhm,
the pendulum one is going to be shared. I mean, uploaded probably just today or definitely by tomorrow. The
mhm.
corresponding video. Actually, there
Okay.
is data which was shared. Was no, I think it is better we stick to the fossil lecture for that. So, Saurabh, did you wish to cover any other aspect?
So for now, we just did the curve fit and very basic aspect of reading and writing files using pandas. Maybe what other can be done is in specifically in astronomy, what we can try to do for next sessions, maybe not now. You can try to do some reading and writing of FITS file for images in using AstroPy
Yes,
and
yes.
different other libraries. Maybe we
Yes, we
can
could
try
do
that in
that,
the
and
next
we
session.
could also have a non-linear curve fitting exercise.
Yeah.
All right. So, Prajwal, more workshops. See, there is nothing hard and fast right now. It's not decided when the next ones will be. First, we are going to see that everyone is caught up with what we have done,
Mhm.
or
Yeah.
any other additional exercise which people want to do. So, you finish that, and in some time. And when we have the next exercise, we'll anyway post in the group, so you'll know through the group when we are going to do. I am also talking to Niraj and a few others, so that like we go step by step into um,
Mhm.
doing more complex things. So, Saurabh, would you suggest we stop here? I will
Yeah.
search if I can quickly find that, but I think the best thing will be that I just upload the corresponding FOSSI file. It will be in the drive. I think everybody has the drive link, right? If not,
Yeah.
I'll share
Yeah.
it once again in the
Mhm.
group. ठीक है फिर
Yeah.
सौरभ?
Yeah, sure. I guess we can now stop here and maybe wait for next time to do some new exercises, maybe.
All right. So the next step is to share the pendulum discussion with you all,
Hmm.
and then I will also share a Google form so that we get back your work in that. So
Yeah.
that's, I mean,
Yeah.
over this week, and the next week probably we'll just try and do that.
Yeah.
So I'm closing the broadcast now.
Okay. Thank you so much.